Every weekend, thousands of top cyber talents get busy hacking each other as a way of staying sharp. Today's presentation will go over what a CTF is, and that is capture the flag, how they are structured, how the University of Delaware has gone from nothing to a top 5 team, and why CTFs are a great way for creating top cyber talent. This presentation is a perfect intro. Our best of Secure Delaware competition occurring during the second breakout session for everyone interested in participating, but that has never done a capture the flag competition before. So going to the one presenting, I introduce Professor
Novocin?
Novocin, okay. Works in web app security, software engineering, and student mentoring. He is the coach of the University of Delaware CTF team, which is a current top 10 U.S. team. He runs the Cybersecurity Scholars Program and has helped many students, founded companies get off the ground. I introduce to you, Professor Novocin.
Okay. Thank you, Ms. Ophelia. Yeah, that's fair. So I coach the University of Delaware Blue Hen CTF team. We started it many years ago now and started nothing or whatever, and now we're a perennial top 10 U.S. institution team. We've probably been as high as number 3, even including all the professional teams and things or whatever. And we hack every weekend, right? So every Friday we're in Evans Hall with pizza from 3 to 5. You can kind of swing on by and just like get the vibes. CTFing is my favorite way to produce useful humans out of a cyber undergrad program. And it's really because it's never patronizing. In fact, what I'm doing here is probably the most patronizing version of CTF, where I'm just going to hold your hand through all these problems, things like that. Typically, CTFs feel like escape rooms in code. You're just thrown in. You're like, hey, there's something wacky going on. Your job is to sort of sniff out what that wacky thing is and go after it. So I'm going to try to give you some shortcuts in leveling you up as like a would-be CTFer, show you some kind of baby concepts that show up all the time. Baby is like probably will create all sorts of emotions in you as you go to CTF. Probably the most important thing in CTFing is like your mindset. To kind of have this screw it, if that guy can do it, I can do it mindset. Because a lot of times the problems are entirely uncomfortable to look at, right? It's entirely an escape room, right? And if you think of doing an escape room, you're like, all right, what do I lift up and look at or whatever and things like that. And so that non-patronizing element of it, I think, is good prep for real cyber work. If you're going to go do incident response or something like that, you're in a SOC, you get an alert, something's happening. Your job is to go Sherlock Holmes that investigation of what is going on inside of your network logs to figure out what, and so building the instincts for the sort of person that can say, something's off here, let's figure it out. So to go from kind of normal education where, like here's a tutorial and a thing and it's well made and well engineered by, education majors and things and it looks like Scratch and you drag and drop your coding into like, here's some crazy crap that you've never seen before. That's the feeling of CTFs. And I think it's very, very pleasant as like a life habit, especially, folks in tech and things like that. Spending a quarter of your effort doing things that just keep you sharp, I think is always smart career-wise, right? And so CTFs always keeps you on top of whatever the CVEs are going on, whatever's going on in the tech trends. If, we had a whole competition that's like how to prompt engineer hack or whatever and things like that and blah, blah, blah. Because just whatever's going on in tech will work its way into CTF problems, right? Okay, so I was giving everybody time to log in and register at securede.ctfd.io. If you happen to be here without a laptop, that sucks. All right, we're going to record this. We'll put the thing out. I'll try to release the problems later. You can solve these training ones that I'm going to do on your phone. It'll just be kind of awkward. Fine. But I've done my fair share of CTFs on my phone from inconvenient locations. Okay. Typically, a CTF competition lasts for 24 to 48 hours over the weekend. And so, and normally you get a team of like 4-ish people or something like that. I tend to think of us as like the best team in the world from like 3 to 5 on Fridays. And then if anybody wants to kill their weekend, we might do well. So like for that window, we're just going to peak. And then if we did well enough, we'll like hang out for the rest of the weekend or something like that. But I've got to tell my wife like, hey, we're actually going to like buckle down on this one or whatever, you know, stay up late and all that kind of stuff. So that 48-hour commitment's pretty hardcore. Okay, so is everybody here? I should maybe have a list of users I can see. So, you know, here's our folks for our live in-person CTF. And I'll show you the places where, you know, I go to ctftime.org to find whatever's currently running. So every weekend we look to see, you know, which competitions are out there. If you're not on there and you're not seeing this, then get there. Here's my plan. By the way, any of you like ringers? Who's a CTF? Any CTF ringers in the audience? Okay, that's good. I predicted that roughly. In case I predicted wrong, I made one steam valve problem. Nobody should attempt that then. Unless you put your hand up for being a ringer. You know, that's just to say, if you just wanted to be here because you like CTFing or whatever, and you're really good, that's one to just kill 1 hour. All right, otherwise don't bother. But I will say that the way I'm structuring this thing, I will release the other 10 problems whenever this section is done. So this competition will go live until 12:20 for being the title of Best at Secure Delaware or whatever. These are real points. I've designed 4 training problems that will teach some like cool online tools, some basic concepts that show up in a lot of CTF's things, give you something that if you find yourself doing a live CTF one day, you'll be like, I'm going to look for one of those things I learned with Prof. Novo. So give you something that you can kind of like look for when you go and look for the baby problems in a CTF or whatever. Then when I release the other 10, I have 4 problems just like these that are like follow-ups, where it's just like this plus, you know, plus. And I'll have problems worth 50, easy problems worth 125, medium problems worth 250, and then hard problems worth 500. Okay. In series, like, you know, 2 hours is not a lot of time. Even a world-class CTF is not going to solve all 16 problems in 2 hours. So, like, you should already set your expectations of lots of failure. CTFs is about accumulating failure. You know, you don't make it in life until you've accumulated 1,000 failures. And so, like, normally it's very uncomfortable to accumulate failures and, like, count that as a positive. Anyway, that's part of why I like it mindset-wise. All right, you ready to go? Let's go. Let's start with old school crypto. So typically when you get into a problem, you've got like a title, you've got a description, maybe some like links, maybe some files. That's it in terms of the mystery of how to get going. Here, I'm going to totally walk you through every last step of this thing, violating the rules of never being patronizing, but that's okay. Let's use CyberChef, pop it up in a new tab. This is a beautiful little tool. Roughly, I can just put in whatever I want, and I can kind of take all sorts of different encodings, encryptions, and things or whatever, and run it through a set of those. So let's suppose I take this hi there, and I want to put it into base 64. Cool, that applied this input, put it into base 64. There's my output. One of the other things you'll notice when you're using this sort of CyberChef interface is that you get this little magic wand. If you ever see this magic wand, it means, hey, I recognize what you've just fed me, and if I do from base 64 on that, I'll get hi there back out. So this just sort of took hi there into base 64 and then took it back out of base 64 to have the output be the input, if that makes sense for that little UX of how CyberChef works. So I can kind of throw that away. And what is base 64? We'll get there. But just to say that I can put stuff in, run it through some number of kind of little algorithms, roughly, and then on the output, I'll get something like that. Okay, that's the tool. I use this tool every single CTF all the time. It's a very fast little way to just kind of fart around with encodings. So let's do this guy. What have I sent you? I've sent you a PNG. Fine. Let's open her up. Oh yeah, I've got some. I'm not screen mirroring since I've got like the admin panel over here. So I'm going to open this up. Move this to the other side. Can I drag you over there? Yeah, sounds good. Boom. Okay. So here is the actual CTF problem. And so what do we do with this nonsense? Well, there's a few things that I'm trying to capture in the nature of this thing. One, I wanted to introduce this CyberChef tool. I think it's very useful for just kind of quickly running through encodings and stuff. Even if you don't recognize them, maybe it'll recognize them for you, whatever, that kind of thing. Two, I'm showing you that I'm using an old school encryption, and I'm telling you which old school encryption I'm using. So we'll figure out what Visionaire is and how to fart around with that a little bit, things like that. Three, I'm also showing you the flag format. So what does it mean to capture a flag and get points for it? Well, there's a string that starts with secure DE, then has some curly braces, and then has some leet speak, 1337 kinds of stuff or whatever, and vowels swapped out for numbers and things like that. So it's got some cheeky little thing inside of there. And your job is to find this string, take it back over to the CTF site, paste it in, hit go, and it'll give you a green check, you found the flag. So typically the flags are designed where if you have cracked the encryption, or you have hacked into the server, or you have created remote code execution, you should be able to find the secret file that has the flag in it, and that will prove that you broke through the firewall. And so this is all sort of proof of hackery. So in this case, I'm letting you know that there's the flag, and the flag format is secure DE. And after I've run it through Visionaire encryption, which you know nothing about right now, conceivably, I got this stuff. Okay? Now, I could have been a nice guy and let you copy and paste this back out or whatever. You all have Google Lens or something. You can grab it out if you want. Or you can just type out the part that matters. But now intellectually, as the puzzle of what we're after here. And by the way, you're never going to see Visionaire encryption inside of some modern NSA thing going on or whatever. It doesn't mean that it doesn't have value as an educator or something like that. It actually is very, very similar to the one-time pad that we do actually use on all encrypted network traffic ever. And it has the same sort of security principles at its guts, but you have to kind of go through a few layers of abstraction to see that. But it's old school. And I think one of the things, okay, yeah, I'm about to go off on a tangent. Let's not do that. Let's get you solving. So how do we get there? Well, so I probably need to get this text out of there and just start typing those out, whatever. So I might need you to shout that out and I can type it in. But let's move over to CyberChef and let me fart around with some Visionaire. Okay? So let's start with just this is some text. So now let's do a little deep dive. And by the way, one of the things I love about teaching with cybersecurity or with CTFing is that it's always just-in-time learning, right? Every single time I do a CTF problem for the first time, I've never seen that thing before. This is an excuse for me to play with that thing. It's the exact opposite of the way that we normally approach academia, which is, I'm going to read this book, this book, this book, this book, this book, and then I'll be useful. Which certs do I need to take before I become useful? It's the opposite. It's saying, you're faced with a real problem. What do you need to figure out to solve that problem? Now go learn that. It's about sort of on-the-fly learning, and how quickly can you do on-the-fly learning. That, I think, is a much more valuable kind of metacognition inside of this than I have an encyclopedic knowledge of everything. That's just never the way it works. And we're all children of the internet now, right? We can all Google search like crazy. And CTFs just say, yeah, go nuts. Ask ChatGPT, do whatever you want. It's fine. OK. So I'm going to teach Visionaire, but Visionaire is not the point. That's what I'm saying here. OK, so how many of you ever heard of Caesar encryption? OK, good number of hands. If not, I'm going to put in CyberChef, Caesar is called ROT13. And here's how that works. Let me Control+ that a little bit. This is some text. So here's how Caesar works. I'm going to take the letters of the alphabet, and I'm going to shift them in the alphabet, going forward. And when I get to Z, I'm going to loop back around and go to A. Okay, so I'm going to start with lowercase t. If I shift this by 1, we expect, what's the letter after T is U. So I expect this to start with a U. H will become an I will become a J, S will become a T, or R, Q, R, S, T. Okay. Boom, U, I, J, T. So that T was shifted up by 1. the H becomes an I, the I becomes a J, etc. All right, you with me on how that works? Let's, now we'll go like amount to, and now you can see that I'm just sort of shifting through the alphabet. And a non-trivial amount of time, I've got this rot 13. If I get all the way around to 26, I'm back to this as text, because there's only 26 letters in the alphabet. So I went forward 26 letters, I'm right back where I started. And so that's sort of like modular arithmetic in a way. All right, you with me on this? OK, cool. So let's talk Vigenère. Vigenère, now, I think it's called the Caesar cipher. I don't know, the actual history. But in theory, it wants us to believe that, Julius Caesar used this crap to encrypt his messages or whatever, just cycled them through the alphabet, hide it. Leonardo wrote his crap backwards and things, so you got to look in a mirror and all this stuff. Vigenère is like the Caesar cipher plus. So let me show this to you here. Now, the keys in Vigenère are going to be letters. So if I put in letter A, my output is literally this is some text. Now I'm going to put in the letter B. Does that look familiar? That was a shift of 1. So the way that this key is working is the letter of the alphabet that I am in is going to kind of add that letter to each of my letters. So sort of taking T plus B is U. And what does that mean? B means a shift of 1, because it's like the next letter in the alphabet. A would be a shift of 0. And it's going to shift everything by 1. All right. Now, dig this. If I go B, C, now this gets a little more interesting. What's happening with the B, C here? The first letter, T, was shifted by 1 to get to a U. But the second letter, H, was shifted twice to go through H, I, J. So what happened is that the B meant shift the first one by 1. But then my next letter in the key says shift the next one by 2. But now I'm all out of key. So went back and started repeating. So the next one I'm going to shift by 1 again. Now I is going to a J. And S is going to go twice, TU. So it's going first shift by 1, then shift by 2, then shift by 1, then shift by 2. And it's just going to loop like that. All right? That's how Vigenère is working here. You with me on that? OK, cool. I'm just reading the nods, right? I will slow down, speed up, whatever, things like that. Nods to say, OK, we're with you. We're cool. All right. Now we get to the data entry part of this. So now how are we going to tackle this thing, and what have we learned from that other image? Well, oh my gosh, can I copy paste? That's fantastic. Seriously? Yes. Oh, that's so good. OK, cool. I didn't know that it would do that. I thought I'd really have to have you shout it out and me type it. But Mac Preview did the job. OK. So what do we know about this thing? Now I have Vigenère encode here is going to go one way. If I swap that out for Vigenère decode, it'll go the other way. So now if I put in a B, it will go backwards in the alphabet. So went from J down to I. So I'm going to kind of undo my rotation. Same deal, it's just the other direction. OK, so I'm going to Vigenère decode this thing. OK. What should be the output? Secure DE. We know the flag format. That's a big deal inside of CTF culture, where knowing the flag gives you just a little bit of predictable plaintext somewhere. And predictable plaintext somewhere is how we won World War II, right? And predictable plaintext somewhere is how we cracked the Enigma. You're like, oh, they say Heil Hitler a lot. All right, cool. I'm going to find that part and then figure out what key would get me Heil Hitler right there, Guys should have less respect. All right. So since we can predict plain text, it does a huge amount in crypto. So I'm going to put in secure DE. And what do I see here? I actually see some English here. And why am I seeing English there? Well, because I'm saying if I rotate by the S, what I actually get out is the letter that I would have rotated by to get S. So what that means is that because it's just rotation, it's sort of like rotate by this much or rotate by that much, it's all the same. Kind of A plus B is the same as B plus A. I can put in my guess for what should be there and get back out the key. And so now if I take that rotated R and put it in as the key, I get secure DE here, but I also get some nonsense. OK, so here's a common sense check. What's wrong with my key there? Actually, no. The exact opposite of that. It's too long. Why? I saw the key, and I saw rotated R. Why is there an extra R there? Because it was looping. It was like the BC, BC, BC. So because it's looping, the key was shorter than that. And I made the key shorter than that because I knew secure DE was how you were going to solve the problem. You force it to be secure DE in that spot. You see what the key would be. And so now if we just drop the R, we get secure DE, welcome to the, oh, crap. So this is totally true, but this is not. And that not being true here probably means that my copy-paste wasn't as good as I thought. Yours says conference. Mine does not. So I'm going to go double check my. But hell, this is good too. And what I mean to say is that a lot of CTFing is sort of like applying a common sense check. I have a math PhD. Every time I make a mistake, I get made fun of, right? And so if you say, hey, how many numbers are between 2 and 5? The quick answer is like 3. It's never 3. It's 4. Subtraction fools you. I always have to double check that crap in my head before I speak. Right? That rotated R is a little bit of a common sense check. That thing's a common sense check. That like kind of live debugging habit is also just a really valuable life skill that doesn't go on a resume. So let's double check what I got wrong. I have actually, you guys can see the original image. Can we validate mine here? I have VONY. 3V.
3QTS. It's the second zero, or the last zero. It copies that as an O.
Oh, it copied that as an O?
Yeah, it was in preview. I have the same issue. There you go.
Ah, okay, fantastic. Ah, okay. Notice the subtlety. Notice the subtlety. I was looking for a more obvious, like, typographical error, like I'm missing a letter or something like that. The letters are there. I started to like worry again as a public speaker, like, okay, gosh, so we catch the O, not the 0. But the Visionaire, like CyberChef thing isn't applying itself to numbers. It doesn't know how to like rotate a number. It only rotates letters. And so when I replaced a 0 with a capital O, it rotated the capital O, which means that the key was now off by 1 for the rest of it. When it was a 0, then the key went to the right letters. So like that little subtle, anyway, fine, great. We have a flag. We get our first little dopamine hit. I get a dopamine hit. You don't get the, you don't feel the same. This is what I'm saying about the patronizing. You don't get the same dopamine hit for getting it on your own when I just like walked you through it. But I will give you another problem just like it at 11:30 when we go live with the second half. And then you can get a dopamine hit that you earned, and that dopamine hit is sweet. Okay. So now we copy that flag, we drop it in here, and we go paste, submit, correct. We're on there. We are now on the scoreboard, We can now see like Blue Benjamin Ben is 50 points in, and I don't know which one is me. Actually, I think I've hidden myself from there, so I don't even see myself on there. Fine. But you'll now get 50 points. You're deep in. You go to the next. All right? Has everybody? So go earn your 50 points real quick, or get and even from the phone, you might, it's a little bit wacky, but you have a Google Lens maybe. You can do this from CyberChef, etc. All right, you with me? Questions, thoughts, or anything like that? This is our first little CTF problem. We're in it now. All right. Next up. Now, I really wrestled and talked with all my friends or whatever. Like, I wrote 4 training problems and then 4 like follow-up problems that are the same concept but with a few extra like layers. I kind of want to release the follow-up problems right now, but public speaking-wise, we're recording this one. I would just sit here and wait for you to solve that on your own or whatever. That's fine. So I'll let you have the dopamine later, but it's delayed gratification. If you're switching breakouts, sorry, you missed out on your dopamine hit. Okay. Stegos. So this is the general topic of steganography. Steganography is, it shows up in CTFs a good bit. It's really pleasant for people to kind of sink their teeth into when they're first getting started. And it's the art of hiding stuff in plain sight. So here's our first little image. Download this guy. Open her up. It's on this other window. Okay. So a little like visual, cultural, anthropological stuff. If ever you're in a CTF and you see a stegosaurus, they're telling you this is a steganography problem, right? So if you see a stegosaurus, your first thought is, oh, cool, they're hiding crap in this image somewhere. My job is to go find it. There's many, many ways of hiding stuff inside of images. I think the connection to real-life cyber is just a little bit silly or whatever, something like that. But, you imagine somebody's got a foothold inside of your system. They're exfiltrating data, but it looks like they're sending out tweets. Fine, those images have got your crap hidden in them somewhere. To recognize that those are like a little bit funky and to, and you're not going to recognize it visually. This actually looks a little bit grainy here. I wish it didn't. That's more just the zoom. The artifacting is non-existent from what I did to hide crap in here. Okay, so let's do some steganography. Now, I play tested these with students and things like that. Let's tell some wacky stories for a second, because the moment I hit this button, everything is revealed. It's probably just a tad too easy. But that's fine. Okay, let's start with this. RGBA values. So what do I mean? Take a look at all these sequence of numbers. Every single pixel of every single image that you've ever seen, typically, is encoded as 4 bytes of data, maybe 3 bytes of data. 1 byte is a byte is 8 bits of data. It's a value between 0 and 255. So you've maybe seen these if you've done some HTML and CSS or something like that. You get these little hashtag codes like OOFFOO or something like that. Every color can be encoded as a value in red, green, and blue. And so these RGB values can be read. So in this case, the very first pixel of this image has a 7 out of 255 for red, a 51 out of 255 for green, 41 out of 255 for blue, and a 255 out of 255 for its transparency, because it's a PNG. PNG likes transparency. OK. So what that means is that I can look at this thing as just zeros and ones eventually. And just there's 4 bytes that encode the first pixel, the next pixel, the next pixel, the next pixel. So here's my observation to you. This is a picture and it makes that. If I were to take this 7 and just plus or minus 1 to any of these values, would you notice with your eye? No. I change it from a 7 out of 255 to a 6 out of 255. You're not noticing that, I've never seen a movie with a Rain Man character who can recognize that or anything like that. It'd make a boring movie anyway. There is a movie called Traveling Salesman where they algorist cracked the traveling salesman problem and the whole world collapses. So I've seen one person try to dramatize my life as an algorist or whatever, but it doesn't make normal everybody content. OK, so plus or minus each of these values, and you won't be able to notice visually. OK, so here's what I did for this problem. I went to all of the red values in this thing, and I just made them even or odd. I just affected the least significant bit. This is called least significant bit steganography. And that is to say, if I think of these numbers as zeros and ones, the highest bit in an 8-bit number is whether or not it's 128 or not. So if they're beneath 128, the first bit's a 0, and if it's above 128, the first bit's a 1. So I went all the way to the least significant bit, which is just plus or minus 1, and make all of them even or odd. So the even or oddness of these numbers is going to have a message in it in black and white. All right, so it will be immediately obvious the moment I start to do this. Fine. We're going to visually inspect what I'd call the bit planes. And that is saying I want to look at all the least significant bits of the red pixels, the least significant bits of the green values of the pixels, the least significant bits of the blue value of the pixels. And I'm looking for some sort of artifacting All right, so when I go to see this, see if you can see anything that might be some sort of secret message. Normally, I kind of expect it to look like random static. All right, so just peel your eyes. Sorry, I know the punchline here. OK. So I just took a whole photo, made it black and white, embedded it in the left-hand column of this. And this is really just there in the even and oddness of the red pixel values of this thing. Is my secret message for my Moscow headquarters or whatever. And we can inspect that for the other ones. Here's the green spectrum. I don't see any artifacting in the green. Here's the blue, no artifacting. And I can go back and look at the red and kind of jump up a bit. Here's the 1 bit. What does that mean? This is sort of, if I have 8 bits of data, the bottom bit was sort of even or oddness. The next one is sort of +2 or -2. So I either I multiply, I added a 2 or I didn't add a 2 in binary for the values between 0 and 255. OK, so this kind of thing of hiding, and you can see if we go up to the top bits, it's definitely not static when I get up to the top, right? You get this kind of, I have a demo somewhere where it's I can actually, one of the other types of steganography that's out there is you can take half. And so the bottom 4 bits is, if I shift that up to the top, this is kind of the image I get. So those bottom 4 bits really don't do a whole lot. They're just, so I can actually throw them out and put a whole separate image in the bottom 4 bits. So I could kind of say, here's an image of Leonardo da Vinci. You click this, it's the Mona Lisa. And you go back or whatever. So to say what you want to hide in those least significant bits is up to you. In our case, just the very first one that we're going to see is the least significant bits of the red pixels. And boom, there's our image. OK, cool. So that's like a baby little stego problem. Online tool, you can do the thing. Stuff is hidden in there. You wouldn't know it to look at it. But I'm telling you that culturally by saying, there's a stegosaurus, this is a stego. Go hunting. All right, you with me? I tried to delay that because the moment I click the button, you're like, oh, cool, I found the flag, or whatever. But I'm going to give you another one that'll be a it will be a stegosaurus. You're going to go here, you're going to do that thing, and then it's going to try to direct you to some other stuff. I'll show you the next things. The next things maybe play with extracting files and data. So here, I embedded this as a PNG. Probably foolishly, I should have put it in green 0 instead of red 0 so I could have more dramatic buildup, whatever. But a lot of times, if I actually want to do that, I could actually just put it in as sort of binary data. This could be an MP3 or something, or I could put it in as ASCII, which is the encodings that we use for all of our normal stuff. And so if I want to look at that same thing from just the zeros and ones perspective, this will be kind of the data. So if I put plain text in there, you can read the plain text that's been encoded. Because I put a whole image inside the image just to, I don't know, make it feel really approachable. But a lot of times it's not an image. It's ASCII values or some other type of binary data that's going to show as text. OK, you with me? That, make a note, use that during the competition. All right. OK, cool. I think I want to be here and hit the backup button to go here. That did have the whole flag. Oh gosh, it's got all sorts of other flags I've typed in the past. I'm leaking stuff. Hidden in plain sight. Now, I might need to rinse and repeat that to get my flag, but whatever. I don't need points. I'm even hidden. So you go get that out. That's fine. All right, you ready for the next one? All right, reasonable format for you? Trying to teach CTFing as quickly as I can, and it's actually a really tough tightrope to walk with, because I want that dopamine hit that comes from you really doing the thing, but also to hold your hand and kind of teach you some cool tools that are useful or whatever. So, OK, let's do the next one. All right, password security. So this one's going to be a web exploitation. All right, let's do it. 11:02. I also need it. So I think anybody switching to the other breakout session after this? Okay, all right, cool. So I was just planning to just go until 12:20 or whatever, something like that. And maybe some hardcore people are coming in for the competition or whatever, something like that. But hopefully it's just us. So I've got it in my head that 11:30 is the transition, but like I don't know if this session ends at 11:25 or 11:20 or something like that.
11:15 and 11:30 is the next session.
Okay, so there's a 15-minute gap between them, which I'm going to largely disregard. But okay, so I'm going to try to time this out so these next two trainings are done by 11:15, and then we'll like close the recording and then we'll start the competition. Okay, password security. Log into this just terrible, horrific website. Okay, cool. That happens a lot in CTFs, you know. Okay, secure Delaware flag me one service.chals.io. Hi. Nope. Password. Nope, etc. Okay, so crappy little website, just a little password box, not even asking a username or anything else like that. So how do we go about making any sort of heads or tails on a little web exploitation thing? Well, the first time I look at a website in a CTF, one of the things I want to look for is, did I provide you source code? If I provided you source code for a backend or anything else like that, great. And this is also true. By the way, all of this, like Exploit Strike, the company on my shirt and things like this or whatever, they're just the president of last year's CTF teams. Like, you know what? I want to do this professionally, and so we like spun up a business to do pen testing or whatever. So the CTF team just graduated in doing real pen testing stuff. So if you're doing a real engagement, you know, do I get source code for that API? Yes or no? Am I just fuzzing it externally or not, or whatever, things like that. So sometimes you do, sometimes you don't on these web problems. In this case, I don't show you my backend, but guess what? Anything that ever runs on your computer, you've got the code for. How do you get to it? Right-click and view page source. Okay. View page source is a feature, not a bug. You can investigate. And a lot of times, if you're on any website ever, you can go view their page source, and they'll be like, hey, you're the sort of curious person that looks at other people's source code. Have a job, you know, like apply to work with us here at these places, right? So you guys can do that too. If you're hiring, you're like, just hide your crap in source code somewhere, and somebody will stumble onto it and say, you found me through the source code? Cool. All right. You're my kind of people. So now, I'm not expecting to know anything about coding or JavaScript or anything else like that or whatever. And that's never the point. And like I said before, this kind of just-in-time learning that happens with CTFing, it's always about, like, I just need to get enough to wrap my head around where the puzzle is or where the vulnerability is and things like that. So what do we see when we see this? Well, which line of code here do you think is like the place where the login is decided or not? Yeah, this password equals, right? And it's not quite password equals, it's MD5 of password equals. Okay, so maybe we don't know what MD5 means. Quick, Google it, right? Pretend like it's a job interview and you're remote. MD5. You know, great. All right, cool. This is called a hash algorithm, all right? And there, you know, I could talk for hours about like, you know, what hashes are and what they do in our world and things like that or whatever. But we've got, you know, 5 minutes to solve a CTF problem before 11:15 or whatever, you know. So what do I need out of hashing? Well, hashing is this sort of technique that people will use to verify data, or in the case of passwords, they'll take your password, they'll hash it into something weird, and then store that instead of your password. So that way, inevitably, when, you know, your ex-lover works at that code company and they have access to the database, they're not seeing your password and trying it in other places or whatever. You know, and inevitably when somebody hacks your Ashley Madison database and they leak all your things or whatever, those passwords just aren't immediately public. They're eventually public. So we hash the passwords. Okay, great. So in this case, the password we need will hash with the MD5 algorithm into this. Okay, now, hash algorithms can be NSA level secure. MD5 is not, but they can be NSA level secure, and it doesn't mean that you can't reverse it. So like reversing a hash is sort of this weird little relationship of what I'd call entropy. It's sort of how much universe of possibilities were there on that password that got to my hash. The best I can do as the coder is to hash really well with a really high quality algorithm or whatever. But if you give me password 123, that's the first trying. You know, and if I leak that hash and I'm trying to figure out which password went to that hash, I'm going to try the 10,000 most common passwords first. And guess what? Your computer can hash, you know, 2 million a second or whatever, right? So like and compute power is really cheap, which means that like you have to be. I could probably spend $1,000 and hash a quadrillion passwords. So if your password is within a quadrillion of the most commonly possible thought of human passwords, I can crack you for $1,000. Okay. And that kind of calculus is say, well, I've just pissed off North Korea. How well do they want to go after this thing, and how much will they spend on it or whatever? They did the Swift Bangladesh thing or whatever. Fine, they got a little extra cash, whatever. So there's this whole calculus. Blah blah blah. Okay, that's not the point. So what do I do with this? Well, I can actually go back to our friend CyberChef if we want, just to explore for a second, and I can over here look for the MD5. You can kind of get a feel just by playing here. If I kind of keyboard cat, you can see the behavior of the output. That is, every new character I add completely changes everything about the hash. I can even just take one character and just kind of capitalize it. Hash is completely different. But the hashes are always a fixed length. And if I take the same input and give it twice, I'll get the same output. So hashes act as this little kind of DNA to text. So you take in some input, it will always hash to the same value no matter which computer is running that hash algorithm. And you can tweak it, and all of it will be completely different. OK, so common sense time. How do you go about figuring out what input would give me this output here in a CTF where you've never CTF before, things like that? What's the first thing you should just try? MD5 decrypt. I was just going to Google it. So like, if anybody has ever indexed this, Google knows. And so if I see anything but 0 results, that password is insecure, right? So if you've got your own password and you hash it somewhere, whatever, and you just Google the hash, if you find anything but 0, your password is in a database somewhere that has been, stored. OK, cool. And right on here is like md5.gromweb or whatever. University of Notre Dame has it. 0 for owned, whatever, etc. So if I kind of go into this thing and say, reverse this hash for me. Oh, not that hash. That was a different hash. This hash. I got too fast for you. OK. So because this password is like not good enough, Google knows it. I can drop it in here, log in, boom. Now, I called it literally published on Wikipedia because the way I found that password is I just looked at the top 10,000. It was like all the Ashley Madison leaks or whatever. And like, here's the top 10,000 most common passwords that showed up in that database dump. And just sort of scanned around until I found one interesting, Great. So we drop that in. Boom. Let's get our dopamine hit. OK, cool. All right, you with me? All right. So that's like a little bit of password storage, whatever. There's a whole set of lectures I could do about like hashes and further things, whatever, blah, blah, blah. But there's like just kind of wacky tools and view source and this kind of thing and getting used to it. OK, let's do some network stuff. I've got 5 minutes to get this network one. Great. This is a PCAP file. All right, PCAP is for packet capture. My model of the internet, by the way, and the tool we'll play with here is called Wireshark. So you can grab Wireshark, you can download it, install it, whatever. This one's a little bit more than just a browser-based, so that's fine. Let's talk a little bit about Wireshark. I'll pull it up. And I'm going to bring it over there. Boom, boom, boom. All right. So this is Wireshark. Now, Wireshark, the internet. Let's talk about the internet for just 1 second. I've only got 5 minutes. Let's just talk about the internet for a second. Here's my mental model of the internet, or a network. We are all holding a copper wire and a little button that can send electricity on that copper wire. That's the internet. So I can go buzz, 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 and you're all like, stop it, jerk. Fine. But communicating on that wire, we don't have like our faces and things like that or whatever, but we're all listening to every packet. So like when I'm on this like wireless endpoint or whatever, I thought it'd be on the roof or something, but it's somewhere. Okay, there you go. I'm communicating on a particular radio frequency, and all of you are listening on the same radio frequency. We're all listening on the same radio frequency. We're just sending stuff. And that means that I can be listening to all of the packets that you are sending. And so Wireshark will do that. So you can just go to a Starbucks, fire it up, and just start listening, and just see all the packets that everyone around you is sending. Because packets are not inherently, secret. They're literally being passed on the internet through just 15, 20 different, internet providers who are routing it from place to place to place to place. Okay, cool. So what we want to do is open up this file that we just downloaded. Okay, and you get some crap that looks like this. Now, learning to kind of see the internet and really see the zeros and ones that are actually broadcast over the radio frequencies, I think it's a very satisfying thing to do. You can see this IP address is talking to that IP address, so that's a little lame. It must be the same IP address. That's true. We cooked up the problem. But it is from one port, 5596, to another port, 8080. 8080 is normally some sort of little node script or some crap or whatever, So if I want to investigate a particular conversation in a Wireshark transfer, again, I could talk for hours about what's going on here. All of these things have whole careers in them, whatever, things like that. We got 5 minutes to solve a CTF problem. So I'm going to right-click, and I'm going to follow the TCP stream. Okay, that's this thing. And actually, this opened up another window on my other box, so this kind of non-mirroring is getting me here. But let me show you what I see. All right. When I followed the stream, this is what I got. All right. You recognize this? That's the HTTP protocol. All right. So this made a post request to upload.php at 192.168.30.166.8080, sending some stuff or whatever. What did it send? pcapflag.png. What's the content? This. All right. What do I see inside of that? A bunch of unprintable crap, but I see PNG at the top. It's an image. So they've uploaded an image. I caught it in my packet capture, grabbed all the captures, collected them all together. I've got the thing. Now, can I read this image? No, we need to right-click some other crap. But fine. So you can go up to File, and I want to say Export Objects from HTTP. And you'll see these are all the things, the files that were sent inside of this packet capture. And so I'm going to grab out the pcapflag.png. And maybe just click Preview. It definitely opened up on the other window. All right. Boom. And there's our flag. OK, cool. So it's just a packet capture. It's there's just two devices talking on a network. And we're just going to follow what happened, grab out a file. The flag's inside of there. All right, cool. Now we've gotten 4 flags. It is 11:15 on the dot, public speaker. Yo, what up? All right. Boom. So, all right. I'm now going to stop recording, switch out of public speaking mode, and I'm going to launch 11 more problems, I think. And it'll be live until 12:20. And you've got until 12:20 to solve as many of as you can. 4 of them are just direct follow-ups to these things. There's a series of SQL injections. And I'm happy to walk around and just coach you through things or whatever, something like that. If the problem says hard, do that last or whatever, unless you're just feeling ambitious or something. You can work on as a team if you want. You will corrupt the scoreboard a little bit. But I think talking is nice, etc. All right, you get value out of that? Cool. You can jump into CTF every weekend of the year, all year round at ctftime.org or whatever. You can come hang out and have pizza with us and hack with the Blue Hens cyber team. Game on.